Hi students, we will learn about the converse of the Pythagorean theorem today. So before we learn about the converse of the Pythagorean theorem, we're going to talk a little bit more about the Pythagorean theorem. So we learned last time that when you have a right triangle and you know two of its side lengths, you can use the Pythagorean theorem to find the third length because there's a relationship that always holds for right triangles, and it is that the smallest side squared plus the next smallest side squared, or the other leg, that sum is going to be equal to the longest side, or the hypotenuse squared. So this is the Pythagorean theorem that we know. We're going to dive a little bit deeper into this. When you have three positive numbers or integers for a, b, and c, such that a squared plus b squared equals c squared, it is known as a Pythagorean triple. So you can test three side lengths to see if the Pythagorean theorem holds true, and if it does, that means those three sides will build you a right triangle. So example 1 is 3, 4, 5, a Pythagorean triple. So what we're going to do is we're going to first assign each number a, b, and c. Remember, c is always going to be the longest side. So we'll say, in this case, side c would be 5. The 3 and the 4 would be our a and our b. Put them up here, a and b. Remember that the shorter leg is a and the longer leg is b, but if you get those two mixed up, it's no big deal. What's really important is that side c is the longest side. All right, so now we're going to put those three numbers into the Pythagorean theorem where a, b, and c are, and see if it truly is equal. So we have 3 squared plus 4 squared equals 5 squared. And we want to see, is this a true statement or not? 3 squared is 9. 3 times 3 is 9. 4 squared is 16. 4 times 4 is 16. 5 squared is 5 times 5, which is 25. And 9 plus 16 does equal 25, which means 3, 4, 5 is one of the Pythagorean triples. So the reason why this is easy, the reason why this is good to know is that you will be able to recognize these. This is a really common triple for right triangles. There are other Pythagorean triples. Here are some other common Pythagorean triples: 5, 12, 13, 8, 15, 17, 7, 24, 25, 20, 21, 29, in addition to the 3, 4, 5. But what's also cool is you can even make more triples than this by multiplying any of these triples all by a factor. So for example, if I was to multiply 3, 4, 5 all by 2, I would get 6, 8, 10, and that would be another triple. So I could multiply any of these by 2, 3, 4, 5, and so on, and I've got an endless supply of triples. So why am I showing you this? These aren't something you have to memorize, but if you can recognize them, they will save time. It's kind of like if you know your multiplication facts, it saves you time so you don't have to get out the calculator. The two for sure that I would definitely try to memorize, because you'll see these a lot, are the 3, 4, 5, the 5, 12, 13, and the 8, 15, 17. I think those pop up a lot. I've seen the 7, 24, 25 a lot too. And then being able to recognize sometimes when you have a multiple of these triples, like the 6, 8, 10, you can multiply the 3, 4, 5 by 3 and get 9, 12, 15, and so on. 3, 4, 5, definitely though, know that one. So before we start talking about the converse of Pythagorean theorem, which is next, I want you to recall something that we learned a while back. If I gave you three lengths and I said, will this form a triangle? The test was to add the two shorter sides, the two shorter lengths, so the sum of the two shorter lengths if that was greater than the longest side, then if you put those together, it will create a triangle. So we need to do that first before we can learn the converse of Pythagorean theorem, which will make sense in a minute. So let's just review this very quickly. If you want to pause and test it on A, B, and C in the next example, you can. Example 2, which of the following can be lengths of a triangle? So remember, you take the two shorter sides. So for A, that would be the 4 and the 5. Those add up to make 9. 9 is greater than 6, right? So since that is true, yes, this one will make a triangle if I put those three side lengths together. So I might have a triangle that looks something like that. 4, 5, and 6. Of course, it's not drawn to scale. All right. B, again, take the two shorter sides. 4 plus 5 is 9. Is 9 greater than the third side of 9? No, it's not greater. So this combination of side lengths will not create a triangle. The last example, C, add the two shorter sides. 4 plus 5 is 9. Is 9 greater than the third side of 10? Nope, it's not greater. It's actually less than, so this one will not make a triangle either. So the first thing you have to do is determine if you can make a triangle, and then in the next slide we will learn, well, how can I then classify the type of triangle by angles using the converse of the Pythagorean theorem. So recall also a while back we learned how to classify triangles by angles. We can either have an acute, obtuse, or right triangle. There also is an equilateral triangle, but that one doesn't really apply here. That's a special type of acute triangle. So the converse of the Pythagorean theorem is just the reverse of it. So the Pythagorean theorem states that if you have a right triangle, then a squared plus b squared equals c squared. The converse or the reverse of that says if a squared plus b squared equals c squared, then you have a right triangle. So a right triangle can be formed when a squared, hold on, let me back up. We're gonna flip the equation for a Pythagorean theorem. We're gonna start with the right side. So when c squared equals a squared plus b squared. And just to make sure we're all on the same page, the longest side is c, the shorter sides are a and b, okay? So if you had these three lengths and you did not know if you had a right triangle, but you squared the long side and it equaled the sum of the square of the two shorter sides, then that means you in fact do have a right triangle. We can also determine whether we have an acute triangle or an obtuse triangle. If we take those three sides and we square c and we add the sums of the squares of a and b, and c squared is less than a squared plus b squared, then we have an acute triangle. If we do the same thing and c squared is greater than a squared plus b squared, then we have an obtuse triangle. So these symbols are what I need you guys to know. So you want to flip the Pythagorean theorem around, so c squared is on the left. If there's an equal sign between the c squared and the a squared plus b squared, then you've got a right triangle. If it's a less than, acute, greater than, obtuse. This is the converse of the Pythagorean theorem. So now we're going to try it with some examples so you can see how to test this. So in these examples, the first thing you need to do is we need to determine if a triangle can even be formed. And we're going to do so by adding the two smaller sides and making sure that it's greater than the third side. So A plus B is greater than C. If it can form a triangle, then we're going to go a step further and we're going to classify it by comparing c squared to the sum of a squared plus b squared. So the first thing we need to do is assign a, b, and c to our three possible side lengths. So remember, c is the long side, so for a, 12 is going to be c, and then the 4 and the 5 can be your a and b. Make sure you know which one is C. That's the important one. So first of all, we're going to add the two shorter ones, A plus B, 4 plus 5, and we're going to compare it to 12. Is it greater than 12? No. So this one won't even form a triangle, so that means we don't have to classify it. We can't classify it. All right, easy. B. Our long side is the 8, and then the 6 and 7 are our A and our B. So the first thing we're going to do is we're going to add the two short sides, A and B. So 6 plus 7. And then we want to see, is it greater than the third side of 8? 6 plus 7 is 13. 13 is greater than 8. So yes, it will create a triangle. Now we want to classify it. So we're going to take C squared. So you're always going to set it up like this. C squared and then A squared plus B squared, and compare those. And whatever symbol goes between them, that'll tell you if you've got a right, acute, or obtuse triangle. So our C is 8, so we've got 8 squared on the left. A squared and B squared are 6 squared plus 7 squared. And then we'll simplify. 8 squared is 64. 6 squared is 36. 7 squared is 49. Well, 64 is definitely smaller than 36 plus 49. So I want a less than symbol here. This less than indicates that we have an acute triangle. And that's how that works. C. Our possible side lengths are 1, 3, and square root of 10. First of all, you need to figure out which one's the longest so you know which side is C and which sides are then A and B. So square root of 10, you need to know that that's about 3 point something. If we had to think of it on a number line, it would be larger than 3, which means square root of 10 is going to be my side C, and then the 1 and 3 are my A and B. So first let's test to see if it is a triangle. We'll add the A and the B, so we'll add the 1 and the 3, and see, is it greater than square root of 10? Square root of 10 is actually about 3 point something, yada, yada, yada. Well, 1 plus 3 is 4, and 4 is bigger than 3 point something. So yes, this is going to make a triangle. Now to classify it, remember we're going to compare C squared to A squared plus B squared. Our C is square root of 10, so square root of 10 squared. Our A is 1, so 1 squared, and our B is 3, so 3 squared. So now let's simplify these. Square root of 10 squared. Remember, anytime you square a square root, they undo each other, so square root of 10 squared is just 10. 1 squared is 1, 3 squared is 9, and 10 equals 1 plus 9, which means we have a right triangle. Remember, an equal sign indicates a right triangle. So we had acute when it was less than, right when it was equal. Let's do our last example. On D, square root of 9, square root of 16, square root of 27, we know square root of 9 is 3. We know square root of 16 is 4. And square root of 27 is 5 point something. So square root of 27 is going to be my side C, and then my A and B are going to be my square root of 9 and square root of 16. So let's first go ahead and see if we can create a triangle. We'll add our A and our B, so square root of 9 plus square root of 16, and we want to make sure that it's greater than the square root of 27. Square root of 9 is 3, square root of 16 is 4, and 7, 3 plus 4, is greater than the square root of 27, which is 5 point something. So yes, this will create a triangle. Now let's go ahead and classify it. Remember, we're going to compare C squared to A squared plus B squared. So So our C is square root of 27, and then we'll square that. Our A is square root of 9, and then we'll square that. and our b is square root of 16, and then we'll square that. Remember, when we square all these square roots, it's just what's under the square root symbol, because the square and the square root are opposite operations. They undo each other. So square root of 27 squared is just 27. Square root of 9 squared is just 9. Square root of 16 squared is just 16. 9 plus 16 is 25, and 27 is greater than 25, which means we have an obtuse triangle. So hopefully this converse makes sense. Write down any questions you have, and I'll see you in class.